Alright, so we're in Unit 3, we're doing Lesson 4 and 5. We're going to talk about negative exponents and how they affect their bases. And when we're done with this, you should be able to understand and recognize what negative exponents do and how you apply them for your own benefit to help solve equations and stuff, or expressions and stuff, and simplify them. Alright, before we get into that, let's talk a little bit more about fractions again. So fractions. Okay, so let's start with the letter x. I presume that letter x is just a number. Okay, that letter x is a number. Okay, there's a lot of invisible stuff going on when I write the letter x. It's a variable. Right? It stands for some number. It could stand for any number, right? But there's a lot of invisible stuff going on with x. Okay. First of all, this is a fraction, right? This fraction is x over 1. All right. So that 1 is invisible, and the divisor bar is invisible, but we traditionally don't write it because to do so would be, a little tedious and it would take up time. So if we write just x, people kind of recognize that it's over 1. Okay. Also, there's a plus sign. There's a plus sign in front of this x, right? It's invisible, so we don't write it, but it's invisible. It's a positive x, and there's a plus sign over this positive 1 in the denominator because it's also positive. So a positive divided by a positive is a positive. So that's a thing too. Okay. There's also an invisible 1 in front of this x. Okay. So there's this 1 that is not shown in front of it. This is an invisible 1. Okay. So there's an invisible 1, which is a coefficient of x. We're saying, hey, there's 1x in front of this coefficient. And there is a, let's see, I'm running out of colors. There is a invisible 1. Oops. There is an invisible, or I'm using orange. I have a pink I can use. There's an invisible 1 as an exponent of this x, right? Because anything raised to the first is itself. And this exponent finally has a sign of a plus sign of 1. Right, so there's a lot of invisible stuff going on for this x. Right, so let's explore what happens when I change some of these things. Right. So first off, if I change, we'll say, the negative sign on the bottom. Right, if I change this negative, this positive sign, I change it to a negative sign. Right, this then becomes a positive over a negative. So everything else not shown, a positive over a negative becomes a negative x. And that's what I have as my answer. Okay, that's all I need to show. Alright. If I change like the 1 and I change it to a 2, right? If I change this 1 and I change it into a 2, it becomes a 2x, right? If I change like the negative in front of the x, right? If I change this from a positive to a negative, and it now is a negative over a positive, I change that into a negative x, right? If I change both of them to negatives, it's a negative over a negative, which is a positive, so now I have just an x, right? If I change the bottom to if I change the top to a 2 and the bottom to a 4, and now it's 2 4x, so it's 1/2 x or 1/2 x or x over 2. Okay. So that's a lot of stuff. If I change the 2. If I change this 1 to a 2, now it's x squared. If I change like this x squared and I change the 2, now it's x squared over 2. Right? So there's a lot of stuff changing here. But what if I change, I got this x over 1 to the negative, or to the positive 1, and I change this positive 1 to negative. What happens then? Well, if you looked back here, when I changed that positive of the coefficient, I had the positive x, right? I had the positive x, and then this is my number line, and this is 0, and then I changed that to a negative x. Well, that changed it and it moved it to the other side of 0. Okay? Well, changing the coefficient of the variable to something completely different. Okay? Changing the variable of changing the coefficient of the exponent of this x makes this x go to the other side of the fraction bar, right? So now this thing is going to migrate to the other side and become positive 1. Nothing left except for a 1 all by itself on the top, because remember this 1 was hanging out up here, right? There's a positive 1x right over here, so the x is now forced to the bottom to become positive, right? And now the 1 again is invisible, so now I just have 1x, right? So what this is saying is, if, hey, I have a negative exponent, right, in order to turn it positive, I gotta send it to the opposite side of the fraction bar. Okay? And it doesn't have to be just ones, right? I could have x to the negative 3, right? Over, by itself, and it's over a 1, right? It would be written like this. It would be written and shown to me like that, but I know it's written over a 1. So I can be like, oh, well, that is written, because it's over an invisible 1, right? That's now written x to the 3rd, 1 over x cubed, right? Because the invisible 1 went to the top, and it inverted the fraction, right? It inverts the fraction, right? That's one way to look at it, okay? So what happens if I have, so one way to look at this is saying this is one of the negative exponent rules. It's saying 1, or x, is saying that any number, b, any base, to the negative equals 1 over b. Okay, that's one of my exponent rules. That's like the most basic understanding. Okay, but you can expand this. This can be expanded to include fractions. If you have, say we have an x and a y, different bases, right? And it's raised to a negative 1. Okay, that's how you write a negative 1, by the way. You don't have to write the 1, you can just say it's a negative sign. Okay, this is just saying, hey, invert this fraction. Okay, so this can also be extrapolated to x to the negative over y to the negative. Now you're saying, hey, both of these exponents are on the opposite side of the fraction bar that they need to be in order to be positive. So let's send them to where they belong. Send them to their homes. Right? So this needs to be y, that needs to be x. Alright. Well, that's cool. So now, what if I had a term outside of this that had like an x to the y, and it was all to the negative fourth. Right? Well, this can be expanded to x to the negative fourth over y to the negative fourth. Right? And so you can then expand this to y to the fourth over x to the fourth. Right? So you can make that jump right ahead. You can be like, okay, x to the fourth, y over to the negative eighth, and you'd be like, okay, well, I'm just going to flip it and apply it. Y x to the eighth. You can do it all in one step if it pleases you. Okay? So that's where that comes in handy. Alright. So, and remember, if there's like a, yeah, we'll talk about that stuff. So let's show you what like this would look like if it was a number. Okay, so if this was like 3 and this was 4, this was all like the 7th, right? This would become, to the negative 7th, excuse me, this would become, well, let's go ahead and flip it. First flip it. This would become 4 over 3 to the 7th, right? Which then becomes 4 to the 7th over 3 to the 7th. Okay, you can flip it and remove the sign, or you can just flip it and remove the sign, or you can distribute the negative 7. It's also the same as doing this, right? You could also be negative 3 to the negative 7 over 4 to the negative 7. And then flip it. You could then flip it. Be like 4 to the 7th over 3 to the 7th. Right? That's the cool thing about these fractions. Okay, so let's give an example. Some examples here. Where'd my mouse go? My mouse. Okay, so here's a good example. Okay, let's do some easy ones. So here's a negative one. Okay, here's a negative one. We have negative 4 fifths to the negative fifth. Okay, so first you have to evaluate the sign. Okay, when we're evaluating signs inside parentheses being raised to a number, okay, evaluate the sign and whether it's being raised to an odd or an even. Okay, that sign being raised to an odd, so this is a negative being raised to an odd. This is our special case, right? Our negative being raised to an odd is going to become a negative number. Okay, this has nothing to do with the flipping. Okay, this is the coefficient being raised to a negative, to an odd number. Okay, completely unrelated with what we were just talking about. Alright, so this is a negative number being raised to an odd number yields an odd result, or a negative result. So our number is going to be negative. Okay? That was this thing. That was this thing. Alright? Being on the opposite side of the 0. Okay? Nothing to do with fraction flipping. Okay? Now we can distribute. Now we can kind of ignore the negative sign for a while. Okay, we already wrote it down here so we don't forget about it. Now this is going to be 4 fifths. We can flip it, be 5 fourths, and then distribute to 5. 5, 5. And that's my answer. Here we go. Okay? Flipping it makes the negative go away, and then distribute to 5. Alright, let's do this one. This one is negative. It's written as negative 1 over 2 to the negative 8th. Okay, this is just fancy. So if I have a negative over a positive, so a negative over a positive yields a negative. Okay, so this is just a fancy way of writing negative 1/2 raised to the negative 8th. Okay, so don't be tricked by anything like that. That's just a fancy way of writing that. This is just a fancy way of writing, or a confusing way of writing this. Okay, so now I have a Okay, now evaluate the sign. Okay, when you're evaluating the sign, it's the sign of this whole thing, of the coefficient raised to an even. When I have a negative raised to an even, anything, a negative or a positive raised to an even is going to be a positive. Okay, so my answer is going to be positive. So if I need to write a positive so I don't forget it, that's fine. Write a positive. You don't have to write the positive because it's not conventional to do that, but I will. Okay. So now I have a -8 applied to a 1/2. So I'm going to flip the 1/2 to make it 2. Okay. Why did I not show the 1? Well, 1 to the 8th, because I'm going to apply the 2 to the 8th. Right, now the negative's going after I flip the 1/2. I'm just going to apply the 8 now, 2 to the 8th. Why did I not show the 1? Well, 1 times 1 is 1 times 1 is 1 times 1 is 1 times 1 is 1 times 1. So it doesn't matter how many times I raise 1 to anything, it's going to be 1. Right, so 1 just disappear into themselves. Okay, so it's just going to be 2 to the 8th. I don't need to show, I can show 1 to the 8th like this. I'm not wrong, it's just unnecessary, right? Because 1 to the anything is itself. Okay? So there's that. This is 2 to the 8th. Okay, so now for the challenge problem. The challenge problem. I have 4, 1/4, the whole thing raised to the 3rd. Well, that's interesting. Okay, times, and this is going to be over 4 to the -5th. Alright, and then this is going to be times 4 to the 4th. Alright, well, let's look at this first. Let's look at the easy one first. What is the, you can't see the red, I'm just going to dispose of that. What is this? There's multiple ways to do this. Right, what is this? Well, remember, this is 4 to the 4th over 1. Okay, so if this is 4 to the 4th over 1, this belongs in the numerator. Right, so I'm going to rewrite this as 1/4 to the 3rd times 4 to the 4th over 4 to the -5th. Alright, so now, alright, well, I have this 4 to the 1/4 to the 3rd. And I got this 4 to the 4th. And the only thing, these all have 4's in them, but this is 1/4. If I inverted this somehow, they would all have the same base, and I would be able to do stuff with them. So how could I invert this fraction? Oh, well, if I took 1/4 and I inverted it, right? If I inverted 1/4, right? If I inverted this, it would become, if I flip the fraction, it just becomes 4, but it's inverted, right? So if I put that in front of it, it equals that. Okay. So I can take this. I had a phone call coming in just a second. Sorry about that. I was gone for a while. I don't remember where I was. So we have a 1/4 to the -3rd would turn into 4th. Sorry, 1/4 to the 3rd would turn into 1/4 to the -3rd. Go by 4 to the 4th. Go by 4 to the -5th. Sorry about that -4th right there. I was in error. Alright, so now, using what we know about negative exponents, or just what we know about the quotient rule, or I guess we could just go ahead and flip everything now. Okay, so since this one here is a negative exponent, this one is a negative exponent, we can flip these and send them to the opposite sides. right? So this one's happy. This one's a positive, happy exponent. It's happy to be in the numerator, so we're going to keep it in the numerator. These are not happy being in the numerator. That's not happy being in the numerator, in the denominator. So we're going to send them to the, we're going to make them positive by sending them to the other sides of the fraction bar. And so this 4 to the 5th. 4 to the negative 5th will become happy and positive by going 4 to the 5th. And it's going to be up there with 4 to the 4th. That's a multiplication dot, by the way. And then we have this one's going to become happy when it goes to the 4 to the 3rd in the denominator. Okay, so now we have like bases in the top that we can multiply together, that are being multiplied together, and it's going to be a 4 like bases have multiplied exponents, become 4 to the 9th. I say multiplied, I mean added exponents. 4 plus 5 is 9, and then it's 4 to the 3rd on the bottom. Alright, and then we have a 4 to the, there can only be one 4 in this whole exponent here, or in this whole fraction. There's only one 4 base allowed with exponents. So they're going to go to battle here, and this 9 beats that 3, right? So there's going to be 4 to the 0th left. When that one reaches 0, it becomes a 1, and this one is now going to only have 6 lives left, and it is now a 4 to the 6th. And there you go. That is how you finish that one up. I hope that makes sense, and hope you enjoy this episode of Exponents.